Hello ma'am. My first question is what is entropy? Please explain entropy for dry and saturated steam, wet steam and superheated steam with the help of diagram. Second question, please solve the problem to find out the change in enthalpy as well as change in entropy with the help of Mollier diagram.
We know that the entropy increases with the addition of heat and entropy decreases with the removal of heat. We will consider here piston cylinder arrangement for which 1 kilogram of water is getting heated under constant pressure from the freezing temperature of water 0 degree Celsius. Now this 0 degree Celsius, that means in Kelvin we will write here 273 Kelvin. Now what will happen when the addition of heat is taking place? So when the heat is getting added, then the temperature of water is getting increased, and due to addition of heat entropy is also getting increased. So we have to show this process on the temperature entropy diagram. So here is the temperature. We have to show increase in temperature as well as increase in entropy. So I will show this process as a process AB. So here will be starting point, that is A, and here will be point B. Now we will move for the next point. So here the heat addition process is taking place, temperature is getting increased and entropy is getting increased until here there is the saturated water condition. Now what is the meaning of saturated water? So after the saturated water condition, if we add extra heat, then water starts to get converted into steam. That means water vapors are there, and there is the no increase in temperature. That means after this point B, temperature will remain same. But we know that the process of addition of heat is continued. So we have to show, because of addition of heat, increase in entropy, but temperature will remain same. Now up to which point we have to show this process? Until all the water is getting converted into steam, this process continue. That means temperature will remain same but entropy is getting increased. So I will show this process with this process BC. Now at this point C, all the water is getting converted into steam. Now after that, if we continue to add the heat, then what will happen? So here, or at this point C, only steam is there. Now this steam is again getting heated, its temperature is getting increased, and addition of heat, entropy will also getting increased. So the next process CD, we have to show increase in temperature as well as increase in entropy. So I will show this. So this is the process CD. Now we will define each and every point of this graph. So what is the point B? So at this point B, there is the saturated water condition. So we will show here as a saturated water. Then process BC. So in process BC, there is the mixture of water as well as water vapor. So there is the wet steam. Then point C. So at this point C, there is dry and saturated steam. And process CD, there is the superheating process. Now we have to define the entropy for each process. So for the process AB, I will show here how we can show this entropy. So for process AB, there is only liquid phase, that is only water is there. So we have to show entropy as a S to the base F. For F we will use for the water phase and G we will use for the water vapor phase. Now during the process BC, there is the water as well as water vapor. So we will use here the entropy, that is SFG. and during the superheating process there is only superheating steam, so we will use here S superheated. Now at this point C we will use here Sg. So I will write here there is the only at this point C, suppose we will show the entropy Sg, then that is the entropy will be at the point C. So this is the entropy that we have to define. Now we will understand what is the formula for entropy. So we know that when there is the addition of heat takes place, entropy is getting increased, and for the removal of heat the entropy is getting decreased. That means we will measure the entropy, that is in terms of change in entropy. So what is the addition of heat? So when the addition of heat for the small rise in temperature dt, that is equal to delta Q. So whenever there is the rise in temperature, suppose we will say during this process, here the small rise in temperature dt, then so this vertical length will show the small change in temperature dt, then during this process the heat is getting absorbed and that is equal to delta Q. So how we will define this delta Q? So delta Q is equal to mCp dt. That is m, that means the mass of the fluid, that is where the small change in temperature is taking place, Cp, that is the specific heat of the fluid, and dt, that is the rise in temperature. Now in this case there is the water, so we have to take Cpw, that is the specific heat of water, Cpw. Then m, so m mass of this water is 1 kilogram, so here if we take 1, then we can also take delta Q is equal to Cpw dt. Now how we will write the formula for the entropy? So we know that the increase in entropy for rise in temperature dt. So increase in entropy, that means we have to write the heat addition process. So heat addition process, that is delta Q, and which is equal to Cpw dt. Now if I divide both sides by temperature T, then ds is equal to delta Q by T, which is equal to Cpw dt by T. So this is the formula to calculate the increase in entropy ds. Now we will solve the problem 1 to find out the final condition of steam as well as change in entropy with the help of the Mollier diagram. So first I will read what is the given problem. Using Mollier chart, find enthalpy drop and final condition of steam when it is expanded isentropically from an initial pressure of 30 bar and 350 degrees Celsius to a pressure of 1 bar. So this was the given question. This is the Mollier diagram, also known as enthalpy entropy diagram. On vertical line, enthalpy is there, that is H in kilojoule per kilogram. And at the bottom on horizontal line, entropy is given, that is S in kilojoule per kilogram Kelvin. Now we will first plot the point 1 as per the given condition of the steam. So initial condition is given, pressure is given 30 bar and temperature is given 350 degrees Celsius. Now we have to first observe where is the pressure of 30 bar. So if we observe these lines, inclined lines, that is 4, 10, 20, then these are the pressure lines. So here is 500 bar, that is the last line is given. So in between 20 and 50 there are two lines. So this line is for 30 bar and then next line is for 40 bar. So we have to select the 30 bar pressure and at the same time we have to select the 350 degrees Celsius temperature. Now if we observe, this green colored line indicates the temperature. So 500 degrees Celsius, 550 degrees Celsius. So we have to select the temperature 350 degrees Celsius. So here the intersection of this temperature line and pressure line, we have to select the point.
and this point, that is for the initial condition of the steam. So we will give here the point, that is the point 1. So I will take this point as a point 1. Now this initial condition of steam is expanded isentropically. So how expansion is taking place? That is isentropic expansion up to a pressure of 1 bar. So we have to take the, or we have to select one line, and we have to extend this line up to a pressure of 1 bar. So if we observe here 0.01 bar is there, 0.05 bar, 0.1 bar. So we have to find out where is the line for 1 bar. So this is the line for 1 bar. Now we have to extend this point 1 in such a way that entropy remains constant. So on this horizontal line, or at the bottom, there is the entropy. So we have to take straight vertical line up to a pressure of 1 bar. So I will select here. So I will minimize the size of the line. So straight vertical line for a pressure of 1 bar. So here is the point of intersection. Now this point of intersection is known as the point 2, because after the isentropic expansion, this is known as the final condition of the. Now we have to find out what is the enthalpy drop and the final condition of steam. So how to find out the enthalpy drop? So for that, we will first find out what is the enthalpy at point 1. Again, I will draw here. We will draw here the horizontal line from this point 1 to find out the enthalpy. So I will take this line. I will use here different color, and we will draw this straight horizontal line. So this is the line. If we observe, we have to find out its a value. So what is the value for this line? That is 3120, and you need the same we have to give in kilojoule per kilogram. So we have to note down this enthalpy at point 1, that is H1. In the same way, we will find out the enthalpy at point 2. So we will draw here the straight horizontal line, and what is the value? That is 2450 kilojoule per kilogram. So now how to calculate the enthalpy drop? That means we have to take the difference in between these two enthalpies. So HA minus HB, that is 3120 minus 2450, which is equal to 670, that is 670 kilojoule per kilogram. Now we will find out what is the final condition of steam. So what is the meaning of condition? That means we have to find out whether the steam is saturated water, or dry saturated air, or superheated, or it is wet. Now for the final condition of steam, we have to observe this point 2. So for this point 2, if we observe here, 0.90 dryness fraction is given. So if we observe this red inclined lines, so this red inclined line indicate the dryness fraction. So we can say that the final condition of steam is the wet steam with dryness fraction 0.90.
Now we are going to solve the second problem when the expansion process is taking place at constant enthalpy, as well as expansion process is taking place at constant entropy. And we have to find out what is the change in enthalpy as well as change in entropy with the help of Mollier diagram. Question is, a sample of steam at 200 degrees Celsius and a pressure of 7 bar is first expanded at a constant enthalpy to 3 bar and then at constant entropy to 0.5 bar. With the help of Mollier diagram, determine the change in entropy and enthalpy during the processes. So this was the given question.
This is the Mollier diagram, also known as enthalpy entropy diagram. On vertical line, there is the enthalpy H in kilojoule per kilogram, and on the horizontal line, there is the entropy S in kilojoule per kilogram Kelvin. Now, if we observe this question, there are two processes that is taking place. That is, the steam is first expanded at constant enthalpy, and again it is then expanded at constant entropy. So we will first select the point 1 for the initial condition of steam. So it is given that it is at a pressure of 7 bar and 200 degrees Celsius temperature. Now if we observe on the smaller diagram, here is the 2 bar pressure, 4 bar, and then here is the 10 bar. So in between 4 and 10 there are two lines. So here the number is 6 and then here the number is 8. Now in between this 6 and 8 there is the pressure of 7 bar. So we have to select the middle point. And now we will find out the temperature 200 degrees Celsius. So here is 650 degrees Celsius, 500 degrees Celsius. Now if we observe here, here is the 200 degrees Celsius. And now in between this 4 bar and 6 bar, there is the pressure of 7 bar. So this point will be point 1. So we will select here, or we will write here as a point 1. Now we will move for the next. That is, again, this initial condition of steam is expanded with constant enthalpy up to a 3 bar. So point 2 will be, we have to extend this point 1 at constant enthalpy. So enthalpy is on this vertical line. So we know that enthalpy is on this vertical line. So enthalpy remains constant. That means we have to draw here straight horizontal line and we have to take 3 bar. So here is the 3 bar pressure. So here is 1 bar and here is 2 bar, and after 2 there is 4. So in between these 2 and 4 the middle point will be 3 bar. So here is the horizontal line. So we have to select the middle point. So if we observe, we will take here line. We will select the size of the line. I will use here the different color and I will extend this for the constant enthalpy. So this middle point is known as the point for the pressure of 3 bar. So this point is known as the point number 2. So we will say, give here the number, that is number 2. Now we will move for the next. So next point will be point 3 for the isentropic expansion. So isentropic means what? Entropy remains constant. So entropy remains constant. That means on this bottom horizontal line there is the entropy. That means from this point we have to draw straight vertical line up to a pressure of 0.5 bar. So here 0.5 bar pressure line is given. So from this point we will draw here straight vertical line. I will choose here the different color. So from this point 2, we have to draw the straight vertical line which will intersect this 0.5 bar pressure line. So this point will be point 3. So I will say, or I will write here, this point is point 3. Now what is the question? So question is that with the help of Mollier diagram, we have to determine the change in entropy and change in enthalpy during the process. Now two processes are taking place. Expansion with constant enthalpy and expansion with constant entropy. Now we will find out what is the change in enthalpy and entropy. So what is the enthalpy at this point 1? So remember, we will draw here this straight horizontal line. I will use here the black color. Now we will extend this point 1. So what is the enthalpy at this point 1? So if we observe enthalpy at this point 1 and point 2 will be same. So we can say that H1 is equal to H2 is equal to 2850 kilojoule per kilogram. Now in the same way we will find out what is the enthalpy at point 3. So again from this point 3 I will extend here one straight horizontal line. Now we will measure what is the enthalpy at point 3, that is 2535 kilojoule per kilogram. Now in the same way we will find out the entropy, because change in entropy that we have to find out. So I will use here different color. Now we will extend this point 1. So we will extend this point 1 and we will find out what is the entropy at this point 1. So if we observe, entropy at this point 1 is 6.84 kilojoule per kilogram Kelvin. Now in the same way we will extend this point 3 and we will find out what is the entropy. Now if we observe here, entropy at point 2 and 3 are same. So S2 is equal to S3 and that is equal to 7.24 kilojoule per kilogram Kelvin. Now these are the enthalpies and entropy that we have to note down. Now what is the question? So first question is, during the first process, that is when the process is taking place at 1 to 2, then what is the change in entropy? So we have to take the entropy at point 2 minus entropy at point 1, that is 7.24 minus 6.84, which is equal to 0.4 kilojoule per kilogram Kelvin. And second question is that what is the change in enthalpy? So change in enthalpy, but enthalpy at point 1 is equal to enthalpy at point 2. So change in enthalpy is equal to 0. Now we will move for the next process, that is the process 2 to 3. So here again we have to find out what is the change in entropy. So change in entropy, if we observe, entropy at point 2 is equal to entropy at point 3. So change in entropy is 0. And what is the change in enthalpy? So change in enthalpy, enthalpy at point 2 and enthalpy at point 3. So what is the enthalpy at point 2? That is 2850 minus enthalpy at point 3, that is 2535, which is equal to 315 kilojoule per kilogram.